Okay, so today we're going to be talking about the derivatives of trigonometric functions. And to do this, we're going to look at the functions of sine x and cos x on a graph. So the red line here is a sine x graph, and the blue line is a cos x graph. And if we wanted to figure out the derivative of one of these functions, let's start with sine x, what we'd have to do is figure out or look at the slopes at each point, because the derivative is really showing the slope at every point. So the obvious ones here would be where the slope is 0 on the sine graph. So here, here. All of these points slope is 0, so the derivative would be at 0. So this one would be at 0, 2, and so this one. So there's 3 points of the derivative of sine x graph. Now other points we can look at for the derivative would be where the sine function crosses the x-axis, like here, here, and here, because the slope at these points is actually just going to be 1. So here, where it's going up, it's going to be 1, so you're going to put a point up here for the derivative. Over here, it's going down, so it's actually going to be -1, so you put a point here. And then here it's going up again, so it's going to be +1. So here are 6 points. And if you look at it, you notice probably that all of these points for the derivative of sine x actually land on the cos x graph. So now if we wanted to look at the cos x graph and figure out the derivative of those points, we could look at the same 0 points again. So it's 0 here, so we can put a point here. It is 0 here, so you can put a point here, 0, put a point here. And if we wanted to look at the ones, it is going up here, where it crosses the x-axis. So this is actually going to be +1. It is going down here, so it's going to be -1. And it's going up here, so it's going to be +1. So now that doesn't actually, none of these points actually match up perfectly with the sine x graph, except for these ones. And what it actually does match up with is if you took the negative sine x and took the graph of that, these would be flipped over, and that would become the same, so they'd match up. So what this all means is that the derivative of sine x is actually equal to cos x, and the derivative of cos x is actually equal to negative sine x. And this is always true. So when we look at this, the derivative of this graph, the sine x graph, is going to be equal to the cos x graph, like we found, and the derivative of the cos x graph is going to be equal to negative sine x, which is this but flipped over the x-axis. So that point there, that point there. Now there are other functions for this too, like tan x, which equals to secant squared x, the derivative of tan x. The derivative of secant x equals to secant x tan x. The derivative of cotangent x equals to negative cosecant squared x. And the derivative of cosecant x equals to negative cosecant x times cotangent x. And so these you can just memorize and use anytime, because they'll always be true. So if we want to take this knowledge and use it for some examples, some practice, we can look at this function right here. F of x equals sine x tan x. So if we wanted to figure out the derivative of this, you notice first that there's trig functions, and also that it's the product rule. So we can go ahead, use the product rule, take f of x multiplied by the derivative of g of x, which is g of x is tan x, so it's going to be secant squared x, like we saw here. And then all of that's going to be plus g of x multiplied by f prime of x, which if f of x is sine x, that means the derivative of sine x, like we learned, is cos x. So this will be your final answer. Now, to do a more complicated question, let's try to find the equation of a tangent line where y equals cos x and x equals pi/3. So this isn't actually part of this lesson, but the equation of a tangent line, the equation for that is y minus f of a equals f prime of a multiplied by x minus a. So what we have to do to solve this question is find all of these components. So if we look at a, we already know a is going to be pi/3 because it's given to us, x equals pi/3. If we look at f of a, we have to plug in a into our function, so it's going to be cos pi over 3, which, if you remember your triangles, is 1 over 2. And f prime of a equals to negative sine, because that's, if you remember what we learned today, is that the derivative of cos of x equals negative sine x. So if we plug that all in, we get y equals to or the equation of the tangent line is y minus 1/2, which is our f of a, equals to negative sine x multiplied by x minus pi over 3.